Hey guys, welcome back to Alumnus. In this video, we're going to be doing some example problems on limits. If you haven't seen Carter's video where he defines limits, I highly urge you to watch that before this one. But if you don't want to, then we'll just jump right into it. So the first thing we will look at when solving limits is a continuous function. For this instance, we will use limit as x approaches 2 for 5x cubed. The reason that we know 5x cubed is a continuous function is the absence of a natural log function and that there's nothing being divided in this function. So there's an absence of a polynomial being divided. So in order to solve this, it's really simple. All you have to do is plug in the 2 into the x component of this equation. So it's going to be the 5 multiplied by the 2 cubed, and that is equivalent to 40. So there's something called the tabular limit. This limit is relevant to when there's a jump discontinuity at a certain point. Let's go with this function that we used earlier, 5x cubed, and let's put the jump discontinuity at x equals 2. So there's no y associated with that x. Now, if we plug in this 2 into this equation with the jump discontinuity at x equals 2, we wouldn't get a y back. So we would have to use x when it approaches 1.99 and x when it approaches 2.01 to find out to guess what x would be at 2. When x approaches 1.99, y is equivalent to 39.403, and as x approaches 2.01, y is equivalent to 40.603. So using this, we can infer that x approaching 2 would probably be around 40. Now the second thing we will look at is Lhopitals Rule. This is only applicable for functions where the limit of x approaches 0 or the limit of x approaches infinity is equivalent to 0 over 0 or infinity over infinity. Now let's see if this function right here will fit this. Now this function can be rewritten as limit of x approaches infinity of x squared over e to the x. Now if you plug in infinity to these, it would become infinity squared over e to the infinity, which is just equivalent to infinity over infinity. So we know it works. Now all we need to do is take the derivative of the top one and the second one. Basically we would be comparing its rate of change while doing that. So limit as x approaches infinity will now be 2x over e to the x when taking the derivative, because the derivative of x squared is equivalent to 2x, and the derivative of e to the x is equivalent to e to the x. Now if you plug in infinity to there, it becomes 2 times infinity over e to the infinity, which would just be infinity over infinity yet again. So that means we can do L'Hopital again for this function. So limit as x approaches infinity would now be 2 over e to the x, because d over dx of 2x is equivalent to 2, and like we said before, the derivative of e to the x is equivalent to e to the x. So now we plug in infinity, 2 over e to the infinity would be equivalent to 2 over infinity, and that is equivalent to 0. The third thing we will look at is how to use algebraic manipulation to solve for limits. In this case, we'll use the limit as x approaches 1 for x squared minus 1 over x minus 1. Now, the first thing that we can see is that we have x squared minus 1 as a numerator. X squared minus 1 could be simplified to be x plus 1 times x minus 1. So now this limit can be rewritten as x plus 1 times x minus 1 over x minus 1. Now these should cancel out, leaving limit as x approaches 1 is equivalent to x plus 1. And now if we plug in that should be 2. Now, as we can see up here, that if you plugged in 1 originally, so limit as x approaches 1, x squared minus 1 over x minus 1. If we just plugged in 1 there, it would have been 1 minus 1 over 1 minus 1, and that is equivalent to 0 over 0, which means L'Hopital would have worked on it too. The reason that you would do algebraic manipulation is that if you had a really hard derivative, but just to prove that L'Hopital would also work on this, you would take the derivative of x squared minus 1 and the derivative of x minus 1, and that would be 2x over 1. And plugging in 1 there, that would give you the answer of 2. So I hope you all have a better understanding on how to solve limits. If you have any questions, comment them down below. If you enjoyed the content, like and subscribe. Thanks for watching.